Hi everyone, in this video today we are going to see about the topic of encoding algorithm for the conversion of digital data into digital signal. In the conversion of digital data into digital signal, there are so many encoding algorithms are used. They are NRZ, multi-level binary, bypass, and finally scrambling techniques. All of you know that digital data is the consecutives of zeros and ones, that is binary data. And digital signals are voltage levels, discrete voltage levels. In case of encoding algorithms, first, let me see about NRZ. In NRZ, that is non-return to zero level and non-return to zero inverted. In case of non-return to zero level, 0 has the high level voltage and 1 has the low level voltage. Two levels are maintained. And here it's possible for the loss of synchronization when there are consecutive zeros or consecutive ones because constant voltage is maintained. In case of non-return to zero inverted, for the zero, there is no transition at the beginning of interval. That means previous voltage is maintained if the consecutive zero is happening. But for the one, transition is happening at the beginning of the interval. Transition means change in the signal level. It's change from high to low or low to high. So it's come under the differential encoding techniques because it's happening through the transition. But here also there is a possibility for the loss of synchronization when consecutive zeros are happening. Because for zeros, there is no way for the transition. When we see about the example, if we want to send the digital data 010011000011, then for the NRZL, high voltage for the zeros and low voltage for the 1. But for the NRZI, for the 0, no transition. But for the 1, it's transition. Change from low to high. And for the 0, no transition. And for the 1, change in transition. And for the 0, no transition. For the 1, again, we can see the transition here. And when we see about the multi-level binary, from the term we can understand there are more than 2 levels are used in this case. For the multi-level binary, there are 2 cases, bipolar AMI and pseudo-ternary. And in the case of bipolar AMI, for the 0, there is no signal level. And for the 1, there is an altering between positive and negative. In the case of non-return to zero inverted, there is no transition for the 0. But here, there is no line signal. That means 0 voltage is maintained for the bipolar AMI. And in case of pseudo-ternary, it's opposite for the bipolar AMI. That is, no line signal for the 1 and altering, transition for the successive zeros for the zeros. If we see the example, for the zeros, no line signal. And for the 1, alteration is happening. And for the zeros, again, there is no line signal. But here, there is no transition, there is no change. But here, no voltage level. That's the difference between NRZI and bipolar MAMI. Here you can see that there is 3 levels are maintained. For the zero voltage, no line signal, and for the 1, high and low. And for the pseudo-ternary also same. Alteration for the zeros and no line signals for the ones. When we see about the biphase, there are 2 cases. That is Manchester and differential Manchester. For the term of Manchester, what's happening is, here the mid bit is act as a clock signal and the data signal. So in every mid data, there is a transition from high to low in middle of the interval for the zeros. And for the ones, transition from low to high. And for the differential Manchester, mid of the data is active only the clock signal. We are identifying the transition in the beginning of the interval. That is, if the transition is happening at the beginning of the interval, that is 0. And for the 1, there is no transition at the beginning of interval. So it's also example for the differential encoding, as we already see that in our Zeta also example for the differential encoding, because here also we are identifying through the transition at the beginning of the bit. When we see it in the Manchester, for the zeros, transition from the high to low, and for the 1, low to high, and for the zeros, high to low, and again for the 0, it should be transition high to low. That's why it's changed up and low. So if consecutive zeros are happening, it will follow this pattern of. And for the differential Manchester, in every bit transition at the mid, because it's a clock signal. But for the zeros, there will be a transition, and for the ones, there will be no transition at the beginning. So for the 1, there is a transition, and for the 1, there is no transition, and for the 0, there is a transition. Again, 0, there is a transition. So when consecutive zeros are happening, here also we can see 2 transitions. So when compared to the NRZ, Manchester can happen 2 times of the signal level transition. So it's also an disadvantage because signal rate forms the more cost. So here, when compared to NRZ, Manchester or differential Manchester makes the double of the cost. So it's also a disadvantage. And as we have already seen in the scrambling technique, NRZ is replaced by the, we are using the scrambling technique for the bipolar AMI. That is, when the consecutive 8 zeros are happening, we are using the B8ZS. That means when 8 zeros are happening, we are just seeing the last one, and if the last one is positive, we replace this with this, and if the last term is negative, we replace with this. Here we can find 2 violations here. The 2 violations are when it's possible with the last positive, here also positive, and consecutive to negatives. So these are the violations. And there are another scrambling technique also, that is HDB3, high density bipolar 3 zeros. When the 4 consecutive zeros are happening, last zero is replaced with violation. So in this case, two things are checking. One thing, how many charges, how many ones are present before it. And the second thing, which charge is the last one, polarity of the preceding pulse. So when we compare the number of polarities before the zeros, if it's odd and the polarity is negative, then 0, 0, 0 and last is replaced with violation negative. And if it's positive, it's replaced with positive. And in the case of even, what we are using is, here we make first one as the positive, and again it replaces with the positive, because fourth one should be the violation, not the first one. So, and in the case of positive, it's replaced with negative, 0, 0, negative. So here we have just seen about all the encoding techniques for digital data conversion into digital signal. I hope you enjoyed it. Wait until we meet in our next video. Thank you so much. If you have any inquiries, contact me on LinkedIn, Sibana Govindaraja. Bye-bye.